Physics but simple. Have you ever looked at birds just casually sitting on power lines and thought, wait a minute, aren't those wires carrying electricity? Like a lot of it? Because in our minds, electricity equals danger. We are taught not to touch wires, not to go near them, but birds, they are just there, relaxing, gossiping, probably judging us. So the question is, why don't they get electrocuted? It's not superpower. The answer comes down to one key idea in physics, potential difference. Now, don't let that term scare you. Think of it like this. Electricity only flows when there's a difference, just like water only flows when there's a height difference. No difference, no movement. Same thing with electric current. For current to flow through something, there must be a difference in electric potential between 2 points. That difference is what pushes the charges to move. Now let's go back to the bird. When a bird is sitting on a single power line, both of its feet are touching the same wire. That means both feet are at the same electric potential. No difference, no current flows through its body. So even though the wire is carrying electricity, the bird is basically just existing at the same level as the wire. Nothing is pushing the current through it, so it's completely safe. But now here's something interesting you might be wondering. What if a human does the same thing? What if you touch the same wire with both hands? In theory, if you are completely isolated from everything else, meaning you are not touching the ground, not near any other object, and both hands are on the same wire, then yes, your body would also be at the same potential. And just like the bird, ideally, no current would flow. But in real life, that situation almost never exists. Humans are usually standing on the ground or close to other objects. Even your shoes might not fully insulate you. And if your skin is sweaty, your resistance becomes even lower. So the moment even a tiny part of your body connects to a different potential, electricity now has a path. On top of that, high voltage lines can cause something called arcing, where electricity can actually jump through the air. So you don't even need to directly touch another wire. It can still reach you. And because our bodies are larger than a bird, there's a higher chance that different parts of us are at slightly different potentials, and that's already enough to allow current to flow. So while the idea is technically correct in theory, in real life it's extremely dangerous. Birds are safe not because they are immune, but because they are small, isolated, and only touching one wire. Now back to the main idea. If the same bird accidentally touches another wire at the same time, or touches the wire and something connected to the ground, then suddenly we have a potential difference. Now, one part of its body is at a different potential than another, and that's when current will flow through the bird. So it's not the electricity itself that's the problem. It's the path that allows it to flow. This is also why humans can get electrocuted when touching a wire while standing on the ground. Your body becomes a bridge and electricity takes that path instantly. Now here's a fun way to think about it. Electricity is a bit like a lazy traveler. It only moves when there's a reason to. If everything is at the same level, it's like, nah, I'll stay here. But the moment there's a difference, it goes, oh, shortcut, and moves immediately. And anything in that path becomes part of the journey. So next time you see birds chilling on power lines, just remember, they are not immune to electricity. They are just very good at not creating a reason for it to flow. And honestly, that's a life lesson too. Sometimes nothing happens, not because there's no energy, but because there's no difference driving it. Physics, but simple.